All right, I promise I'm not going to bore you to death with nerd stuff on a piece of paper. I'm just going to draw out a few things, and then I'm going to show something that I made that's a really cool troubleshooting tool. So in this scenario, we have a thermostat over here that's sending Y out, and Y goes through the low pressure switch and around to the contactor, and then of course our contactor is also connected to common. Now, we've all had those situations where we get a complaint about a unit not running, and every single freaking time we look at the unit, it's running perfectly. And so we start to suspect that a safety might be going out under some unusual condition and locking the unit out. So how, with an automatic reset safety, like a lot of low and high pressure switches that are automatic reset, how can we tell if it tripped at some point that we weren't there? There's a troubleshooting procedure for that I wouldn't say that it's very well known, but there are plenty of techs that know about it. And what it involves is you take and put in parallel with the safety a very, very low amp fuse. We're talking about very low amp, like maybe 10 milliamps, something like that. So obviously electricity prefers the path of least resistance, so under normal circumstances it's going to go up and through to the contactor. But if this were to open, the electricity is forced to go through this fuse to activate the contactor, and this fuse will blow because the hold-in current for a contactor is like 130 milliamps, something like that. So you can come back then and look around at your fuses that you placed around and see which one blew, and then that'll give you an idea of what safety is causing the unit to lock out. There's also a version of this that is sold. It's called a tattletale. For whatever reason, it seems unbelievably difficult to get those in 24 volts from my supply houses. I have no idea why, but they're all for like 120 volt controls and all that. In addition to that, these low amperage fuses can be hard to source, and on top of that, they can be unbelievably expensive. So a little bit ago, I just got to thinking about that, rolling it around in my head over and over, thinking, is there something that I can make that's just very simple, reusable, and can do this? So, through the magic of editing, we will get our setup. Here's our circuit, very simple. Contactor's pulled in right now. If the low pressure switch opens, contactor de-energizes. All right, now let me set something else up. Here's the circuit now, and the only change that I've made is that this little device is now in parallel. So you can see our contactor is closed. I can open and close it like normal. So the unit is running, and I want you to focus right here while the low pressure switch cuts out. You ready? So then when the low pressure switch resets, contactor comes back on, and it can operate like that. Safety still works. It's just that our little fuse wire in here is now blown. So if we were to take a flashlight and shine it in here, we could see that the little wire that I put between here is gone. Let's talk about the design now, some of the benefits and some of the potential problems. So I made 4 of these. Here they all are. And I made them so that all the magnets stick together. And it's especially nice to have these sides sticking together, and that'll help like stabilizing and stuff while they're bouncing around in your van. Because one of the biggest dangers here would be if these magnets were to break loose and stick together. So then your safety would actually be bypassed. But I have them pretty well potted with hot glue, and also the way that these wires are, even if they break loose, it'll be pretty hard for them to come together. Now, as far as the connections, it is possible to solder onto magnets. You have to do it in kind of a special way, and the magnet ends up being about 80 to 85% as strong afterwards. But for the most part, it's nice not to solder on them, because these will lose magnetism as they get hot. So I've just soldered this onto a steel washer. Nothing special there, just normal solder and flux. You just got to make sure you have an iron that'll get hot enough. Then I'm using these spades here because obviously it allows you to hook into any of your safeties that are spades already. Gives you a tap. But in the event that you have a wired safety, I would clip the wires and put in this pair so it can be reconnected. But in the meantime, while I'm testing it, this is just going to get slid into here. And I suppose I would have to use an uninsulated. And then of course, weather would be an issue if this is like on an outdoor unit. And it goes without saying, this is for low voltage only. 24 volts, obviously you're not gonna hook this up to 120 or 240 controls. So in the weather, probably, obviously, you know, these get taped up so they don't short out. And then probably just gonna throw everything in a bag with the wires hanging out the bottom and zip tie it together. Okay, another issue is you saw that little wire blow, and we're going to talk about what that wire is and everything here in a minute. But you saw that little wire blow and those sparks. Every time that I've done this, it's never failed to activate, and those little sparks go out instantly, whether they're in here or not. So if someone were to argue that this is a little bit of a fire hazard, I don't know that I could argue against that per se, but in reality, the chance of that happening is practically zero, especially if it's in a plastic bag. It's not a whole lot different from a fuse blowing. It's just, you know, this is not like a certified case. Fuse enclosure, whatever. For the wire, I kept racking my brain and trying to think, all right, so what is easy to get a hold of that I can put in there that will work well? I looked into like really thin tungsten wire for scope crosshair repair, and it's too expensive, and I just kept racking my brain and came up with this. So this is 4/0 steel wool, just the finest that is made. Keep a little piece in here, and then you want stainless steel tweezers. This is hard to do on camera, and I know it's really hard to see, I'm sure, but you're just gonna pull one of these hairs out. And I'll put a link to these tweezers, not just any stainless steel tweezers. They would have to be a low carbon grade, like the 300 series, so it's not magnetic. Anyways, so I'm just ripping off a little hair. It's really hard to do on camera, and just dropping it down in there. Obviously, you don't want it to hang over or anything, but the magnets are just really good at holding it. Let me get this positioned, and I'll see if I can get the light right to show it. Off camera, it doesn't take long at all. You can set one in just a few seconds. And you see that little dark line right there? That's the hair. And again, kind of hard to see on camera, but when you shine a flashlight into this, it is very, very obvious whether that thing is there or has blown up. There it is in a reflection. It is really easy to see in person. So then that's it. You're ready to go. And this method of having the magnets hold it has been really reliable. I haven't had any kind of like false or any cases where it is not activated. At first I was working on something that would kind of clamp the wire, but this ended up being a much better solution. Some of these intermittent problems are just unbelievable, really hard to diagnose, and so that's where something like this comes into play. Now, we could do some further testing, like for example, if the low pressure switch is feeding into a board, would this still blow? Like, could it still trip in the, with just the small amount of current that a board pulls? I doubt it. I really do. But as far as amperage is concerned, this is one of the lowest amperage things I've ever messed with. I mean, you can't hear the transformer buzzing, the contactor doesn't budge. There is very, very, very little current able to pass through this without it tripping. So I would like to do some tests, but it appears to me to be very, very close to 10 milliamp fuse, if not even finer than that. Well, I hope that was educational, maybe just entertaining. Anyways, let me know what you guys think. If you want to have a video on like some further testing and stuff, I might be able to do that at some point. But otherwise, I hope this might help somebody out. And again, I talked about the problems. If you're not comfortable with this setup, I get it. You know, this is just a prototype, not recommending that anybody use this. But at least you can see how the method works, and you might be able to order some tattletales or something like that from one of your supply houses.